Maayong buntag sa tanan. Welcome to Science 7 Quarter 4 Week 3, the types of seismic waves. This is under the learning competency. Explain how earthquakes result in tsunamis that devastate shoreline communities. My name is Ma'am Love and I will be with you today in this video. If you find this video helpful, please do show your support and subscribe to my channel so that I could continue creating similar contents and videos. Please do also leave a comment on this video. For this week, these are our lesson objectives. Number 1, identify the different types of seismic waves. 2, explain how earthquakes result in tsunamis. And 3, realize how tsunamis devastate shoreline communities. These are the teacher's suggested resources. Day 1, short review. Can you recall the anatomy of an earthquake? Let us have a short review. Label the anatomy of the earthquake by choosing the answer from the pool of words beside the picture. Please pause this video before proceeding to checking the answers. These are our answers. Focus is the point within the earth where rock under stress breaks, resulting in an earthquake. An epicenter is the point on the earth's surface that is directly above the focus. Seismic wave are the vibration generated by an earthquake, explosion, or similar energetic source and propagated within the earth or along its surface. Let us watch a video presentation about earthquake scenarios and tsunami.
All across northern Japan, they felt it. A violent magnitude 9.0 earthquake on March 11, 2011. It was centered about 80 miles offshore, and tsunami warnings went up immediately. In coastal cities, people knew what to do next: run to higher ground. It's from these vantage points on hills and in tall buildings that incredible footage was captured. In Tsunami, people retreated to a high-rise rooftop and could only watch in horror as tsunami waves inundated their city, knocking buildings into rubble and mixing into a kind of tsunami soup filled with vehicles, building parts, and contents. Seawater cascaded over sea walls and into cities. This video shows the water rushing over an 18-foot seawall into Kamaishi City. The seawall here was the world's deepest and largest, but not enough for the magnitude of the March 11 disaster. It was the largest quake ever known in Japan, and one of the 5 largest recorded in the world. More than 28,000 people are confirmed dead or missing. When 2 tectonic plates push together under the sea, the resulting earthquake sends an enormous burst of energy up through the ocean, displacing enormous quantities of water. With the upward motion, a series of waves expands in all directions. In deep water, these waves travel fast, up to 500 miles an hour, but only reach a height of a few feet. A passing ship might not even notice. But as the waves enter shallow waters, friction with the ocean floor lowers the waves' speed, but raises their height. This video is from a Japan Coast Guard ship confronting a tsunami wave in shallow water on March 11. And a rare view from the air, video of a tsunami wave approaching the shoreline. In Japan, some tsunami waves reached as far as 3 miles inland. Japan may be the most seismologically studied country in the world, and with more than 1,200 high-precision GPS stations, a geophysicist at the University of Alaska used the data to create a visualization of the March 11 quake. The waves of displacement that you see were moving as fast as 5 miles per second. In this photo, the ripples of tsunami waves are seen moving upstream in the Naka River at Hitachi Naka City. New technology left an enormous amount of visual evidence for study in years to come, and can perhaps help us better understand the power of earthquakes and tsunamis and prevent loss of life in the future.
Video presentation guide questions. What is your reaction about the video? Based on the video, how are tsunamis generated? What are the possible damages brought by a tsunami? Day 1. Let us have a discussion of what are the different types of seismic waves. The types of seismic waves can be categorized into two, the body waves and the surface waves. Body waves travel through the interior of the earth and have a frequency higher than the surface wave. Surface waves are waves that flow along the earth's surface air boundary or into the crust. They have lower frequency than body waves. They are easily identified and are responsible for earthquake-related damage and devastation. Let us proceed to the types of body waves. First one is the P waves. The P waves, are also known as the primary waves, are known as the pressure waves. They may travel through both solid and liquid materials. They move quickly and are the first to reach the seismograph. They propagate through a substance by compressing and expanding it alternately. The particle's velocity is parallel to the direction of wave transmission. Another type of body wave is the S waves. S waves, also known as the secondary waves, can only propagate in hard, solid materials by vibrating particles in a direction perpendicular to the propagation. As a result, they cannot spread across a liquid. Seismologists could verify the existence of a liquid outer core of the Earth by investigating the paths of S waves. The surface waves. The first one is called the Rayleigh wave. They are named after the British scientist Lord Rayleigh, who predicted their existence. Their motion is a mix of longitudinal, compressional, and dilatation. As a result, the particles travel elliptically in the vertical plane. These waves are dispersive, and their amplitudes often decline exponentially with depth in the Earth. The second type of surface waves is the Love wave. This is named after the British mathematician Augustus Edward Love. According to him, the particles of love waves jerk back and forth perpendicular to the direction of wave transmission, much like the S waves. The motion of love wave particles forms a horizontal line that is perpendicular to the propagation direction. The energy of love waves radiates in two directions rather than three. The amplitude often diminishes significantly with depth. Love waves move quicker than Rayleigh waves. Let us try to check your understanding. Let's have a formative assessment. Identify the types of seismic waves. You will be given 3 minutes to answer this portion. Pause this video before proceeding to the next slide. Day 2. Activity 1. The Seismic Waves Simulation. At the end of this activity, you should be able to classify the different types of seismic waves through a hands-on simulation. Please refer to the direction below. Here is a rubric on how you will be graded for this activity. Guide questions. What causes an earthquake? How does the magnitude of the earthquake affect the damage that it causes in the community? And what happens if the earthquake is generated underwater? Identify which type of seismic waves is represented by Setup A, Setup B, Setup C, and Setup D. How do waves might impact structures and communities during an earthquake? Which among the types of waves can cause the most damage and why? Checking the answers. Day 3. Formative assessment. Check your understanding in the types of seismic waves. Identify what type of seismic wave is shown in the illustrations. Checking the answers. Day 3. Teacher's demonstration. Demonstrate how water reacts with vibrations. The material needed: a shallow tray or dish, clear if possible, water, speaker with a strong bass output, music player or device to play low frequency sounds, and a rod. Your teacher will demonstrate to you the occurrence of tsunami. Answer the process questions. What did the speaker produce that made the water move? What will happen if there are bigger vibrations produced? Thinking big. Is it possible for bodies of water to be moved by vibrations? Let us have activity 2, Tsunami Simulation Model. At the end of the activity, you should be able to understand how tsunamis can devastate shoreline communities and the factors that contribute to their destructive power. The materials are the following: a large shallow container, sand or soil, small toy buildings, trees, and people are optional, water, plastic spoon, and rug. Please follow the instruction for this setup. Here is the rubric and how you will be graded for this activity. Make sure to conduct a proper simulation and answer the guide questions. Guide questions. What happened to the building and infrastructure when the tsunami struck? How did the waves affect the shoreline and the area inland? What challenges might the community face in the aftermath of the tsunami? What measures could be taken to mitigate the impact of tsunami on shoreline communities? Let us check your answers. When tsunami struck, the buildings and infrastructure in the simulated community were likely damaged or destroyed. In real-world scenarios, the force of the waves can cause buildings to collapse, while flooding can damage roads, bridges, and other infrastructure. In some cases, buildings may be swept away entirely by the force of the water. The waves affected the shoreline by causing flooding and erosion. Note that as tsunami waves crashed onto the shore, they inundated low-lying areas, damaging coastal structures and vegetation. Inland, the force of the waves can carry debris and sediment, causing further flooding and damage to areas further from the coastline. The challenges that the community might face in the aftermath of the tsunami are the following: loss of life and injuries among residents, destruction of homes, buildings, and infrastructure, displacement of residents who are left homeless, difficulty accessing clean water, food, and medical supplies, disruption of essential services such as electricity, communication, and transportation, environmental damage and contamination of land and water sources, economic hardships due to loss of livelihood and businesses. The measures that we could take to mitigate the impact of tsunamis on shoreline communities are the following: We need to educate residents about tsunami preparedness and evacuation procedures, including the location of safe evacuation routes and assembly points. We need to conduct regular drills and exercises to test emergency response plans and ensure that residents and emergency responders are prepared to effectively respond to a tsunami. Implement early warning systems to alert residents of an impending tsunami, allowing for timely evacuation. Establish and enforce building codes and land use regulations to ensure that new construction is located away from high-risk area and designed to withstand tsunami impacts. Develop and maintain natural barriers such as mangroves, sand dunes, and coastal forests to absorb the energy of tsunami and reduce their impact on coastal communities. Invest in infrastructure improvements such as seawalls, tsunami resistant buildings to protect shoreline communities from the destructive force of tsunamis. And additional to your study notes, the displacement of the seafloor during an earthquake leads to the formation of a tsunami. When an underwater earthquake occurs, the abrupt movement of the seafloor displaces a large volume of water. This displacement creates waves that travel outward at high speeds, forming a tsunami. Formative assessment for Day 4 in checking your understanding in the types of seismic waves. You will be given 10 minutes to answer the 10-item formative assessment. Answers. Sa harap ng sakuna, laging tandaan na ligtas ang may alam. Thank you for watching this video, and I hope that you find this video helpful to you. And if you do so, please do show some support and subscribe to my channel, as this would help me in making similar videos and contents like this. See you again next time on my next video.